we have studied about the structure of the triple bonds in alkynes, and we have studying about the isomers of alkynes. We have seen the positional isomers of butane and the positional and chain isomers of pentyne. Now we will start the structural isomers of hexyne. So, hexyne, this is C6H10. Okay. So, how many structures of hexyne are possible? So, the first one is the straight chain hexyne. Okay. So, this we will call hex 1 ine. Now, the number 2 can be this. We will call this as hex 2 ine. The next one can be, if we shift the triple bond to one more carbon, this is hex 3 ine. Now, if we again move the triple bond to the next carbon, then we get structure 2 again. So, these 3 are the positional isomers of hexyne which have 6 carbon chain. Okay. Now, if we write some branched alkyne with 5 carbon chain, one is this. So, we can name it as 3-methyl pent 1 ine. Okay. So, the next one will be 4-methyl pent 1 ine, and the next one will be 4 we can write this as 4-methyl pent 2 ine. These 3 molecules have 5 carbon chain. So, they are positional isomers to each other and chain isomer to the first 3. The next isomer of hexyne will be So, we have reduced the longest chain to 4 carbons. Okay. We will write this as 3,3 dimethyl but 1 ine. So, these were the 7 structural isomers of hexyne. Okay. So, number 7 is the chain isomer to all of these previous isomers. So, we have completed the structure and isomerism of alkynes. Next, we will discuss about the preparation of alkynes. Okay. So, the first preparation of alkynes is from calcium carbide. From calcium carbide, which is CaC2. Okay. This is a major process for industrial preparation of ethine. Industrial preparation of ethine. Okay. So, what is calcium carbide? This is CaC2. Now, its structure is C2. It is like this, C triple bond C, and there are two negative charges. So, we can collectively write it as C triple bond C 2 minus, and calcium has a plus 2 charge. So, this exists in this form. Okay. So, calcium carbide is prepared from calcium carbonate. So, this is calcium carbonate. On heating, it forms calcium oxide plus CO2, that is carbon dioxide. Okay. Now, calcium oxide, when it reacts with carbon, it forms CaC2 plus carbon monoxide, that is CO. So, like this, calcium carbide is formed by heating calcium carbonate. Now, this calcium carbide is used for the formation of alkynes. So, we will take calcium carbide, we will react it with water, and it gives, see, ethine has a formula of C2H2, we have C2H2. So, we get C2H2 plus calcium and oxygen is left. So, calcium oxide. So, this is the preparation of ethine from calcium carbide. The next preparation is from vicinal dihalide. Okay. So, when we were reading about alkenes, we had studied about the vicinal and geminal. So, vicinal means in vicinity, that is the adjacent carbons. This is called vicinal, and geminal means attached to the same carbon. This is called geminal. Okay. So, from vicinal dihalides, we can prepare alkyne. We had previously prepared alkenes from vicinal dihalide with zinc, but here also elimination reaction will occur, but we need some stronger base. So, let us say we have this vicinal dihalide. So, in the first step, we need alcoholic KOH, which will form alkynyl halide. And from this alkynyl halide, we will again add sodamide. So, sodamide exists as Na plus and NH2 minus, and it is highly basic. So, on addition of sodamide, we will get alkyne. Okay. So, let us look at the mechanism of this reaction. So, let us consider this vicinal dihalide. So, first of all, we are adding alcoholic KOH. So, OH is basic, it will take one hydrogen, this hydrogen will come here and it will eliminate one bromine. Okay. So, what is happening? OH was taking H. So, H2O is eliminated, that is water, and when this Br minus will go out, we have K plus in the system, right. So, KBr is also eliminated, that is potassium bromide. So, as a result, we get this product. Okay. Now, for the next step, already one double bond has formed. So, we will not be able to abstract one more proton with alcoholic KOH. We will need a stronger base. For this reason, we use sodamide. Okay. So, sodamide has Na plus and NH2 minus. So, NH2 minus will take up one hydrogen, this bond breaks and bromine is liberated. So, since NH2 minus had taken up one hydrogen, so ammonia is liberated, along with it sodium ion is left and bromine is leaving. So, NaBr. Okay. So, in this step ammonia and sodium bromide is liberated and a triple bond forms here. We get an alkyne. Okay. Now, the next reaction is from geminal dihalides. Okay. So, geminal dihalide means, we have seen that geminal means attached to the same carbon. Okay. So, both of these process, that is from vicinal dihalides and geminal dihalides, both of them can be called dehalogenation. Okay. Now, in geminal dihalide also reagent will be the same, that is sodamide and alcoholic KOH or NaOH. Okay. So, here also we have, let us see the mechanism. So, let us take one geminal dihalide. Okay. Now, in the first step, we have alcoholic KOH. So, the same mechanism will occur. Now, in the second step, we will have sodamide. Right. So, we get this alkyne. Now, the second step is stabilized due to this double bond. So, of course, as we have mentioned earlier, we need a stronger base. Now, there is another example. So, if we have this geminal dihalide and we have two types of reagents. One is alcoholic KOH and the another is sodamide. Okay. So, if we use more of alcoholic KOH, then we get selectively an internal alkyne. Okay. And if we use sodamide, then we get selectively a terminal alkyne. This is the difference between these two reagents. One reagent will selectively give an internal alkyne and the other reagent will selectively give a terminal alkyne. A third method is dehalogenation of tetrahaloalkanes. Dehalogenation of tetrahaloalkanes. In this case, we have a compound like this. So, we have 4 halogen groups. This is quite similar to the Wurtz reaction. So, here we will use 2 equivalents of zinc. So, 2 zinc means, and there are 4 halogens. So, we will get 1 alkyne and 2 ZnCl2. Okay. So, this is the last method for the preparation of alkynes. So, in the next lecture, we will study about the physical properties and chemical properties of alkynes. Thank you.